Thank you everyone for joining us here today. We're going to cover running a Spark job on DataStax Astra, and we're going to be doing this using Spark Submit. And a little housekeeping, if you have any questions, please direct them to the chat. And if you're watching this on YouTube, you can leave a comment down below and we can respond when we can. And we'll go ahead and get started. So a little about me, my name is Arpan Patel. And one of the recent series that I did was doing SQL and reporting on Apache Cassandra with open source tools. Of those tools, we covered Presto, Spark, open source notebooks, various different ones, and open source BI tools, also various different ones. And this is somewhat of an extension of our Spark in Cassandra. And Spark, we're taking a deeper dive into running jobs, and then Cassandra, we're taking a deeper dive into DataStax Astra. If you're here with us last week, we did connecting Apache Spark and DataStax Astra. So we connected Apache Spark and DataStax Astra using Spark Shell. This week, we're going to be running a job which would require Spark Submit. And if you want to watch the YouTube video for that, you can go to our YouTube channel, youtube.com/AnantCorp. And while you're there, go ahead and subscribe. And then also, if you want to check out the GitHub repo that's associated with last week's webinar, and then also this week's webinar, the link is there as well. And then the blog and slide shares that go in accompaniment with the previous webinar. All right. So a little background information about Apache Spark. It's a unified analytics engine for large-scale data processing. It achieves high performance for both batch and streaming data. We're just going to be focusing again on jobs, like we mentioned, but it uses a state-of-the-art DAG scheduler, query optimizer, and a physical query engine. It offers over 80 high-level operators that make it easy to build parallel apps, and you can use it interactively with the Scala shell, Python shell, R shell, or SQL shell. Last week, again, like I mentioned, we used the Scala shell in Spark shell. And then also has different libraries. So there's the SQL library, data frames, ML Live for machine learning, GraphX, and the streaming libraries, and you can interconnect these all within the same application. And then when running Spark, you can run it in the standalone cluster mode, which we will be doing today, and we'll show you how to do it. And then you can run it on other container technologies, such as like Mesos or Kubernetes, and then you can access data and all different kinds of data sources. Again, like I mentioned, we're going to be focusing on Apache Cassandra with the focus on DataStax Astra. And what we're going to be using as our dev environment is something called Gitpod. Gitpod is an open source Kubernetes application that provides fully baked collaborative development environments in your browser, and it seamlessly integrates with GitHub, GitLab, and Bitbucket. And we'll show you how easy it is just to get started from a GitHub repository straight into GitHub. The IDE itself is based on the open source Eclipse Thea project. And then you can have pre-built dev environments, and then that way you can automatically prepare your Gitpod upon startup. And you can do this via Gitpod Docker files and Gitpod YAML files. And then they have professional developer experience. So you can import and use VS Code extensions that you normally use on your local machine. They also have full Linux terminals that you can utilize. And a couple other cool things Gitpod does is that they have integrated code reviews and snapshots, so you can do a lot more collaborative work within your team, all in a browser-based dev environment. And then this week, because we're running a Spark job, we're going to be using something called SBT. SBT is an open source build tool for Scala and Java projects, similar to Maven and Ant. You could do what we're doing today using Maven and POM.xml, but we're just going to be using SBT. I've already given you the packages and the code for it, so the build properties files, but we'll take a look when we get to the demo. And then SVT also has native support for compiling Scala code and integrating it with other Scala frameworks. You can do continuous compilation, testing, and deployment. And then it also does dependency management using Apache Ivy. And something about that with your Ivy2 cache, I'll mention it a little bit when we get into the demo. And then you can also mix Java and Scala projects, which is pretty cool. And the main reason we're using SVT is so that we can package our code and then also package our dependencies and create jars that we'll then submit with our Spark submit to do our job. All right. So we'll go ahead and get to the demo. You see here, there's two links. So the first link is the GitHub repository for this. And the second link is the link if you have your account already authenticated, your GitHub account authenticated on Gitpod. All you need to do is copy and paste that second bullet or just control click it and open it in a new tab. And that will automatically spin up Gitpod that's opening this exact repository as your dev environment. I've already done that to respect everyone's time. Sometimes it can time out if it's just been sitting there for a period of time. So luckily we're still good. But if it does time out, it's a one-click refresh and it's all get back up and running. So we're going to take a look at the repository. So like I mentioned, this repository is for both the last week's webinar where we covered connecting Apache Spark and DataStax Astra through a Spark shell. So that would be handled in the connect directory. This week, because we're running a job on Apache Spark, we're going to be using the job directory. So if we go ahead and click the run an Apache Spark job on DataStax Astra, a little overview what the demo is going to be about. We're going to run two jobs on our Astra database. The first Spark job. So if you were with us here last week, or if you watched the Connect Apache Spark and DataStax Astra webinar, we live demoed how to do this, and we're going to be expanding upon that demo. So if you haven't watched it, you could go back and watch the webinar first and then come back and watch this, or you can just go to the other README and read about it. So essentially what's going to happen is we're going to use that same table. We're going to seed 2 records instead of 1. And then from that table, using Spark, we are going to create 2 new tables. And we're going to seed those new tables using the data that's in our first table. So the first Spark job is going to take the leaves data, and it's going to create 2 data frames using Spark SQL manipulations. And then each of those data frames, one is for the leaves by tag and one is for the tags. So the leaves by tag is going to extract the tags that are associated in the leaves table and create a tag list. And each of those tags will have a URL, title, and the other tags that is associated with. We'll take a better look if you're not following me, but this is just a quick introduction. So then that first Spark job that we're doing, it's going to create the table. But because we create the table with the first Spark job, we can't rerun that code because that table's already been created. So we have a second Scala class that will run the exact same code, except the create table lines. And so that way it'll just upsert the current existing items in the leaves by tag and tags table. All right, so we'll go ahead and get started with the demo. With step 1, we're going to go ahead and download Apache Spark 3.0.1, and we'll just copy and paste that into our terminal. And while that runs, we're just going to move along to the next part. So the next part, we're going to run Apache Spark in standalone cluster mode with one worker, like I mentioned in the slide deck. All right, so we are going to cd into job, and then we are going to cd into Spark. And then we are going to sbin /sbin start master. And so when we run our master, you'll see these 2 notifications pop up. We'll just need the port 8080 that's because that's where the Spark UI shows up. So we can just hit this open browser button and it'll show us our UI. So we can go ahead and copy this because we're going to start one worker. We're going to copy the master URL and we are going to run /sbin start slave.sh and then paste in our master URL. All right, and if we go back to the master UI and refresh it, we should see our worker, and we do. Great. So now moving back to the README, the next part is downloading Astra Secure Connect bundle, which is essentially the auth packet we will need to talk to our Astra database. If you have not already created your own Astra database or account, you can follow this setup instructions for this repository under Cassandra.API, which is an open source application for DataStax Astra. It has a front end, it has a back end API. That's one version is in Python, one version is Node, and we have a C# version coming soon. And if you scroll down to the setup, you can follow these instructions to set up your account and how to download the Connect bundle. And so if we go to our Astra table or Astra dashboard, sorry, you can click on whatever database you're working with. And when you do this, the UI has changed a little bit, but all you need to do is scroll down a little bit. Oh, nope, that is, I want the Node.js driver and USE Secure One bundle. So this is the bundle we'll be using. So all we want to do, like it mentions in the README, we want to drag and drop it into the Gitpod directory. That's also the really nice thing about Gitpod. We can drag and drop. So we just make sure we put it in the right directory. Just because I've downloaded this bundle a bunch of times, I'm just going to rename it. So it's just the absolute secure connect dash your database name. So if I hit OK, let me close this out. Don't need that. So if we go back to the README, now we're going to download a DataStax Studio notebook. And with this notebook, I have already written out the cells for you. So that way you can just quickly spin this up in Gitpod, run the cells in DataStax Studio, and do this Spark job on yourself. And then if you want, you can fork it and then do whatever else you want with it. If you want to expand on it, play with your own database and make your own Spark jobs, you can. But this is just a quick how to get started. So if we go ahead and download this notebook file, so I already have this open. So I'm just going to go ahead and download it. And then all we need to do is in our Astra dashboard, if we go to our studio, all we need to do is just drag and drop. And so now here we have one statement, which is our create table. So we're going to have a table called leaves. Within this leaves table, we have, think of it as a link collection. So we have an ID associated with each record. There are tags that go with that specific record. So if you say, well, I'll explain it when we get into the seeding, but then there's a title, a URL, a created at, language, reading time, user ID. So user ID here would be whoever added the link. And then the primary key is going to be the ID. So if we go ahead and run this, make sure you select your key space that you have for your Astra database. And we're just going to go ahead and hit run. We're going to look at our schema, make sure our table shows up, and it does. So like I mentioned, we're going to seed the table. The first table leaves with 2 items. So there's going to be an ID. There's going to be tags. So you see how it says GitHub open source Cassandra. And the title of that record is Cassandra.API. That's what we just looked at, where if you need to follow the instructions to get started with Astra. And then we have the URL for that, timestamp, language, reading time, user ID. And then we also have a second record, which is for the YouTube of last week's webinar, connecting Apache Spark and DataStax Astra. But you notice the tags and the ID, obviously, but the tags are a little bit different, right? So we have a YouTube, webinar, Cassandra. Ooh, now we have 2 Cassandras. And then we have a Spark. And then the link for that, timestamp, language, reading time, user ID. So we'll go ahead and seed the table, and then we will just make sure that it's there, and we do. Now we have 2 records. So now, if we go back to our README, we are going to download SBT so that we can start working on our Spark job. So we're just going to go ahead and copy that, paste it into our terminal. All right. So now in our job directory, we have our SBT directory, we have our Spark directory, then we have this directory called Spark Cassandra. And the Spark Cassandra is where our job code exists, and that's where we're going to start our SBT server. So if we look at the Spark Cassandra directory, I have already given you the project directory and the source. Sometimes you can add the target directory, but when running SBT server, it already creates it for us because that's where when it packages and puts the jar, it's going to put it in that target folder. But within this project directory, we have a build properties file and we have a plugins.sbt file. The build properties file is very simple. It just says the SBT version, but this plugin SBT file is where I talked about the IB2 cache in the slides. So SBT has different methods in which we can package and compile our jars. So there's SBT package, and then there's something called SBT assembly. SBT package creates a thin jar. And that thin jar is just a jar with our code in it. It doesn't have the dependencies wrapped within the jar. So when we're running our Spark job code, we'll need to attach Spark submit -- packages and then whatever packages we need. But when we do something with SBT assembly, it creates a fat jar. And when we do SBT assembly, it wraps our dependencies and our code all within. So we don't need to say Spark submit -- packages. We can just do Spark submit and then whatever else we need. So that's the nice thing about fat jars. And we'll be using a fat jar today just because it makes the Spark submit a little bit cleaner. So you don't have to pass in 3 different packages that you don't need or that you'll need, but you don't need to put them into your Spark submit line. So also in our Spark Cassandra directory, we have our build.sbt. So in our build.sbt, this is where we defined what dependencies we'll need. We're saying we need Spark Core. We're saying we need Spark SQL, but we append them with the provided because Spark, when you run Spark submit, it provides those packages. However, we do need the Spark Cassandra connector from DataStax, and we do not append that with the provided. And also, if you notice this code right here, merge strategy and assembly, if you try running the fat jar without lines 12 through 15, you'll get deduplicate errors due to IV cache issues. So what this does is it handles that for us. And so that way, if you need to update your Spark code and rerun assembly to rebuild your package, this will allow you to do that without running into those deduplicate errors. So that's why we have lines 12 through 15. Okay, and then within our Spark Cassandra, we also have our source directory. And within our source directory, we have a directory called main. And within our main directory, we have our Scala directory. So the first job that we're going to run to create the 2 tables is going to be called spark-cassandra.scala. And we're going to package that under Spark Cassandra. And the first object class we have is leaves. And so just a quick walkthrough of what the code is. We are going to start Spark session. We are going to pass in app name, master URL. What we'll need for Astra and connecting to Astra via Spark, we'll need this config called Spark Cassandra connection config cloud path. And that is essentially just the file name. So it's secure connect and then your database name. And then we'll also need username, password of your Astra database. And then when we run our Spark submit, we are going to pass in our actual file. So the actual path to our secure connect bundle. And so what we're going to do is once it's connected, we are going to set our database as our database's name, whatever you plug into line 15. And then we are going to access our data using spark.sql. So the first data frame we're going to create is called leaves by tag. So we're going to essentially extract the tags column as tags. We're also going to select the title URL, and then again, we are going to select the tags. But what we're going to do with this first option, because we renamed it as tag, so even though these two columns are the exact same, but just have different names, we're actually going to explode the first column, like I mentioned, right? Because we are going to have a list of tags, and then each of those tags will see the title URL, and then also the other tags that tag exists with. But we can see all the different kinds of tags we have and what items are that. And then when we look at the result of that in DataStax Astra Studio, I'll explain a little bit further of what we can do with that kind of data. And then the second item, or the second data frame that we create, called the tags DF, that's going to select tags as tag again, and we're going to explode that as well, so that way we can break up all the tags. And then we're going to group by, so that way we can then get a count of each one. So if you want to display however many tags you have, or however many links or the number of items that have that tag, we can do that. So say, remember how we looked in the seeding? We saw that the first two items we added to our leaves table, they both have Cassandra. So after we run this first Spark job, we should see that Cassandra should have a count of 2. And then, so like what I mentioned, this first Spark job, we're going to create the table, and we're going to create leaves by tag, and we're going to use that data frame and then use the create Cassandra table function. And we're going to name it leaves by tag. And then you don't have to set partition key columns and clustering key columns, but we will need to, because if we only do it by tags, which would be the primary key that it automatically takes, they would just upsert on each other. So there would only be one row per tag. So that's where we have to utilize some data modeling, and we would say the primary key, or the partition key of the primary key, would be tag, but then there would be a clustering column of title to provide extra uniqueness, so that way we don't have upserts, unintentional upserts. And then we're just going to write that data frame into that newly created table, and then the mode append, so it would just add to it. And then for the tags data frame, we're going to do the exact same thing, minus setting primary and clustering column, or partition and clustering columns, because we want unique tags. So because we're already collecting counts because they're grouped, we don't need to set extra uniqueness on them. And then we're just going to do the same thing and say tags, write the data frame into Cassandra. All right, so now let's go back to the README. And so we'll go ahead and start our SBT server in Spark Cassandra. So we are going to open a new terminal, and then we are going to cd into job Spark Cassandra, and then we're going to run period sbt bin SBT, and that is going to start our SBT server in our Spark Cassandra directory. It's going to take a couple seconds because it has to download the packages. But while we do that, let's go ahead and take a look at the rest of the README. So like I mentioned, or I hadn't mentioned that, but we have values that you can use to input your own specific credentials in lines 12 to 16 of that first file. And then you will need to save the file. And then like what I mentioned about the thin and fat jars, we're going to be using assembly to build a fat jar, because that way we can wrap our dependencies with our code. We're going to run SBT assembly within that SBT server that's running. And then we are going to submit it. And so what I mentioned before, we'll need to submit with -- files, and then we'll need to point to our path of our database. And then we will also need to pass in our jar. And because I've already done this for you, this jar file won't need to change when you're doing it on your own. The only thing that you'll need to do is just update this your database part, because my database is going to be named differently than your database. And while SBT is still running in the background, if we did a thin jar, so after this class, if we have this slash, we would need to do dash dash packages, whatever packages we did. So like back in our build SBT, the dependencies we downloaded was Spark Cassandra connector by DataStax. We would need to add the dash dash packages, whatever the file name for that is. But because we're doing this with the fat jar, we do not have to do that. So SBT should be good. And we have. So now we have started our SBT server. And so if we go into our code, we are now going to edit the values in Spark Cassandra Scala. So I'm just going to close these extra files. So my username is username. Password is password. Master URL. So we'll just go back here, copy and paste. Database name minus demo, key space is test. So all I need to do is hit save. And now I can run assembly in my terminal. And so now it's downloading, compiling packages, so it can wrap everything together in one jar. And like I mentioned, now you see how we have our target directory. Sometimes people give it to you, or it'll automatically get created. Okay. Just got to give this a little bit of time, just because it's the very first time it's running. So now if we go into our target directory, and if we go to Scala -2.12, and then if we go into classes, we'll see our jar here. The Spark Cassandra assembly 0.1.0 snapshot jar. Like I mentioned, that's going to be the same for everyone in terms of naming, so you don't need to change that part of it. And so we have these two classes. So this leaves class is from Spark Cassandra. This update class is from these update Scala. And like I mentioned, it's the same exact code minus line 40 and line 37, which create the tables. Because again, if we tried running this code after we've already run it once, if we tried to submit the same exact job, it's going to fail because we've already created the tables. So now we can go back to the README and we can run our first Spark submit job. So let me actually go ahead and copy this into a notepad, so that way I can add my database. So like I mentioned, mine is called demo. I'm just going to copy this. And now we are ready to run our first Spark job. So if we go into our terminal that has our Spark directory, so make sure you're in Spark 3.01. So we're going to go ahead and hit Control V, and we should now see our Spark job going. And you're going to see some errors that you could ignore, but we will see one defining method that says we have connected to Cassandra right here, connected to Cassandra cluster. So that's a good sign. So now we're seeing that our tasks are happening, and now we should soon see that our tasks are getting completed. And while that's running, let's actually look at the Spark UI master. If I hit refresh, we should see our running application, and we do. So we know that when we set the master URL in our Spark code, it connected properly, because in our Spark submit, you could say -- master and then put the master URL there. But again, because we already wrapped that in our Scala file, we don't need to do that within our Spark submit. So if we go back to our terminal, it looks like it has been completed, successfully executed, clearing session cache. Great. So now if we go into our Astra Studio, and if we move down to cell 4, so remember we've created 2 tables now, and if I hit this run local quorum on cell 4, we should see let's see, GitHub should have a count of 1, open source will have a count of 1, Cassandra will have a count of 2, YouTube will have 1, webinar will have 1, Spark will have 1. So if we hit run, great, we see that 1, 1, Cassandra, 2, open source 1, webinar 1, Spark 1. So we know that our explodes worked, our grouped by worked, and our counts worked. And we did all of this using the data frames in Spark.sql. So now if we do leaves by tag, we should now see this new table that we created from our data frame. So per tag, so that tag is our partition key, title is our clustering column. So we only have one for YouTube. So YouTube, the first title, and then tags associated with that record and the URL for that record. GitHub, like I mentioned, also has one. You see how Cassandra, it's the same title as the YouTube tag because they both they have the same tags. They have the same title and URL. But now if you're on a front end and you have a list of tags and you want to see, hey, what links are under Cassandra? If I click on the Cassandra item, we should have 2 items, right? Because we now have the partition key is Cassandra, but then we have extra uniqueness with the clustering column that is title. If we only had the partition key as tag, this whatever secondary or whichever one came last right wins. So that would upsert whichever one this was. So whichever one was the latest one between these would upsert that. So there would only be one record. But because we added a clustering column of title, we now have extended uniqueness. So even though these both have, or no, going back to the UI, so if I click on Cassandra, I should now see 2 titles. I should see 2 links, 2 sets of tags. So now we can expand on this and we can go ahead and go back to the README. So we've checked the results and we know it worked. So now we're going to add a new record to set up the second Spark job. So if we go back to the studio and we run this last cell. So in this one, we are going to add another one that has GitHub. So now our GitHub count should go up to 2, and we should see 2 GitHub records. So it'd be GitHub Cassandra API and then GitHub, whatever the title here is, which is Apache Spark and DataStax Astra, which is essentially this repo that we're working out of. And then, so Cassandra, so count should get to 3 for Cassandra. Spark is going to get to 2. So Spark only has 1 record here. So Spark is connecting Apache Spark and DataStax Astra, but then we're also going to have Spark, Apache Spark and DataStax Astra, and then the tags and the URL for that. So we are going to go ahead and run this. And then let's go back up to cell 3 to just confirm that now we have 3 records in our leaves table. Great. And we do. So now we can go back to our code. And if we now go to update Scala, so following the README, so we're going to edit the values in update.scala, and we're going to add the same credentials into lines 12 through 16. So it's going to be username, password, master URL. Just going to go ahead and copy this, paste it in, database name demo, key space test. Once that's saved, if we go back to our SBT server, all we got to do is run assembly, make sure we're saved. And again, like I mentioned, if you ran this assembly without this handling in the build SBT, it will fail. So you will need this kind of error handling to that way it'll clear the cache and drop items. That way we can just rerun assembly without any deduplicate errors. So now that we have our updated item, so if we look in our classes, you see how we have update class and we have this leaves class. This update.scala, our class/object is update. So if we go back into the code, we see that there's no create Cassandra table. There's no create Cassandra table, but essentially the code is exactly the same. It's still doing the same things. It's exploding tags, it's grouping by, and it's counting for the 2 separate data frames. So now we will go ahead and go back to the README, and then we will run this second Spark submit. So you'll notice that there's a little bit of difference. So we're saying that our class path, instead of it's being leaves, which is associated with spark-cassandra.scala, we're saying spark-cassandra.update, which is associated with update.scala. So then we'll go ahead and run demo here, or insert demo for your database name, copy and paste into our terminal with our Spark. So we're going to paste it and run it. And then if we go back to our UI, we should now see one completed application. And then we should see our running applications. So if I refresh, great. So this is the first one that ran, and this is the one that's currently running. Okay. Just give it a little bit of time to complete. Alrighty. So now let's go to our Astra and let's look at our tags table again. So if we look at our leaves table, so we have 1 Cassandra, 2 Cassandra, 3 Cassandra, we have 1 GitHub, 2 GitHub, and we have 1 Spark, 2 Spark. So we should see 3 for Cassandra, 2 for GitHub, and 2 for Spark. And let's go ahead and run that. And we do. So we have 2 for GitHub, 3 for Cassandra, and we have 2 for Spark. So we know that our job ran correctly. It read from our Astra database. It manipulated code with Spark SQL, or manipulated the data with Spark SQL, and then it inserted back into our Astra database. So now let's just confirm one more time with the leaves by tag. So now we should see 3 items for Cassandra, 3 rows for Cassandra, 2 rows for GitHub, and 2 rows for Spark. And if I hit run, and that's exactly what happened. So now we have 2 rows, 2 separate records, but they both share the GitHub tag. So you see how we're still showing the tags that are associated with that record. So the first GitHub record has different tags than the second one does, but they both share that GitHub tag. So then if we go down to Cassandra, it's the same exact thing. We have 3 different rows. And then if we go down to Spark, again, we have 2 different rows now. And that about wraps up our demo. And it does. So we visualize the results. So I hope you were able to take something away from this demo. You can go ahead and fork this repository and make any changes, play with the code, because it's relatively just templated for whatever you need. So if you just want to play with your own data model, you can adjust the code as necessary, because Spark SQL is pretty simple in terms of once you get the hang of it. All you need to do is just change different ways you're extracting data from your tables. So you would just need to say what table you're looking for, or just whatever SQL statements you're trying to derive your data frames from. And then you can also do extended manipulations on top of this, but this is just pretty simple. Get started quickly and just understand concepts of SVT, thin jars, fat jars, how to run the process of packaging, how to submit the package or submit the jar, and overall just run a Spark job in DataStax Astra. All right, we'll go back to the slide deck. Again, I'd like to thank everyone for joining us here at Anant. We do scalable fast data. Our main focuses in architecture are Cassandra, Spark, and Kafka. If you want to ally on your Cassandra platform, don't hesitate to reach out to us at anant.us, or you can email us at solutions@anant.us, or you can call us at the number listed below. And again, if if you're watching this on YouTube, if you have any questions, don't hesitate to leave a comment in the comment section, and we will get to them when we can. And I will open the floor up again to questions, and you can go ahead and direct them into the chat now. All right, looks like no questions. Again, I'd like to thank everyone for joining us here at Anant. We do scalable fast data. If you want to ally on your Cassandra platform, don't hesitate to reach out to us at anant.us, or you can email us at solutions@anant.us. And if you're watching this on YouTube, don't forget to like and subscribe, and we hope to see you soon. Thank you.